Hi everyone, welcome to the channel. Let us understand the Trionic Array problem. So what is a Trionic Array? It is a special subarray present in an array having three parts, where the first part is strictly increasing, followed by the second part strictly decreasing, and the last part is strictly increasing again. For an example, on the picture we can see the array 1305 is having one Trionic subarray. 1 to 3 is strictly increasing, 3 to 0 is strictly decreasing, 0 to 5 is strictly increasing again. So we can say we have one Trionic subarray present in this array. So what is the problem? So the problem statement is we have to find the Trionic subarray having maximum sum. For an example, let's take this another example with a little bit more elements where we'll understand the problem clearly. The array is 0, -2, -1, -3, 0, 2 and -1. And the question is find the maximum Trionic subarray sum. Let's focus on the subarray that is bound between the two dotted line -2, -1, -3, 0 and 2. We can clearly see the first part is increasing, second part is decreasing and third part, which is -3 to 2, is increasing. And the sum of the total subarray is -2 plus -1 plus -3 plus 0 plus 2, which is -4. We can see there is another Trionic subarray present, -2 till 0. But that is not the final answer because that is not giving us the maximum subarray sum. So the question is to find the maximum Trionic subarray sum present in an array. So let's jump into the intuition. But before that, let's first go through the constraints. The constraint is the length of the array starts from 4 and it can be as large as 10 to the 5. The element in the array can vary from 10 to the power 9 to 10 to minus 10 to the power 9 to plus 10 to the power 9. Also, it is guaranteed that at least one Trionic subarray exists. So let's go to the approach. The approach is simple. We will iterate over the array. At each index I will try to calculate the Trionic subarray ending at that index. We will calculate the sum and will update the global maximum. The tricky part is, in order to calculate the Trionic subarray sum ending at a particular index, we will maintain three variables. The first variable is the sum of first segment of a Trionic subarray, which is increasing. The second variable is the sum of second segment, which is decreasing. And the third variable is the sum of third segment, which is increasing again. Let's name it last maximum positive state sum, last continuous negative state sum, current continuous positive state sum. We'll see why we have named these variables like in coming slides. Here comes the intuition part. Since we are dealing with increasing and decreasing trend in an array, it is important to maintain a state. The state that tells us whether we are in increasing or decreasing or neutral state. So, like you guessed, we will have three states. Neutral state represented by 0, increasing state represented by 1, decreasing state represented by -1. And based on the next element, we will change the states between. Let's understand some of the variables that we'll use in this solution. The first one is sum ending at array. So it is the array that stores the maximum sum ending at that particular index on the same trend, which means if the trend is increasing, it will store the maximum subarray sum ending at that particular index having the increasing trend. If the trend is decreasing, it will store the maximum sum of the decreasing trend ending at that particular point, which is continuous. And if the trend is neutral, simply it will store the element itself. Second type of variable is state, obviously, to store whether we are at increasing trend or decreasing trend, or we are at neutral trend. So accordingly, the state value will be 0, 1 or -1. Coming to the segment sum, like we have discussed before, we will store 3 segment sum which will keep updated at each iteration. First one is sum of the first segment. If you observe, the Trionic subarray consists of 3 sums. The first part which is increasing, second part which is decreasing, and third part which is increasing again. And if I want to maximize sum of the Trionic subarray, I will maximize my first segment. So basically, I will store the last maximum positive state sum, which indicates what is the maximum positive state sum possible in the last positive flow. The second kind of sum will store is last continuous negative state sum. If you observe the Trionic subarray, the middle part is always continuous. We cannot skip anything from the middle part. So it is always sum of all the elements of the middle part. That is why we are naming it as continuous negative state sum. The third part is current continuous positive state sum. The third part is again increasing, and again we cannot skip any element on the third part ending at particular index. We'll have to take the continuous elements. So it is again the current continuous positive state sum. Coming to the fourth variable, which is the global triple sum, which is what's the maximum Trionic sum possible in an array, which will keep updated at each iteration. So let's jump into the logic part of our algorithm. So first we will initialize our variables. So we will consume the first element of the array. We will set the sum ending at 0 to norms of 0. We will set the state at 0, that is neutral, and we will make every segment sum to -infinite to indicate it is not set yet. Also, we will set the maximum triple sum, which is our answer, to -infinite to indicate that it is not set yet. If you closely observe, we will be having 3 states at each index. Either it would be increasing or decreasing or neutral. Also, at each index, we will have 3 options based on 3 conditions. If the current is greater than previous, or it is less, or it is equal. So based on these, we will have 9 algorithms based on these 9 conditions. So which state and what is the comparison result between the next and current. Let's see how these 9 conditions will implement their logic. We have already covered the first part, which is the variable understanding and initialization. Let's go to the second part, which is array iteration. So we'll iterate from index 1 to n-1 because we have already consumed the first element during our initialization state. At each index, we will see what is the state. If the state is 0, which means we are neutral state. So far, we have not entered into our Trionic subarray. So if we see an element which is less than the current element, or it is equal, we will stay in the neutral state, because the only possibility to move or to start our Trionic subarray is an increasing trend. So either we see an increasing trend or will stay in the neutral state. So in the else part, which means the current element is greater than the previous element, now it is the start of our trionic subarray, which means we are now entering into our first segment, which is increasing. So we will make the state as 1, which is increasing. We will make the sum ending at I to be norm of I minus 1 and norm of I, because it will store the maximum positive state sum. So the previous element is also part of positive trend. For an example, if you are at 2 and now you are seeing 3, both 2 and 3 will contribute to the sum ending at 3. So it will be 5. And also we will instantiate the current continuous positive state sum to be 5 again, which is sum ending at I. Now coming to the increasing state. So let's say you are already in the increasing state. Now you come across the same element, which means you are going into the neutral state. So whatever part of your trionic subarray you have found so far will not make any sense. So you have to reset everything. You will reset all the segment sum to minus infinite to indicate that now you are in neutral state. You have to start fresh. You will make the state 0 to indicate you are now at neutral state. And since you are at neutral state, the sum ending at I will be same as the array element, which is norms I. Let's come to the second condition. That means you are in increasing state, which is 1, but now you see the element is less than the previous element, which means now you are going into a decreasing trend. This is going with the trionic subarray flow, that after increasing you will encounter a decreasing trend. So now what will we do? We will move to state minus 1 to indicate now we entered into the negative state. Also, the last maximum positive state sum will be initiated. So what last maximum positive state sum indicates that what was the last maximum positive state sum in my current flow. So this will be nothing but the sum ending at I minus 1. The last sum will be my last maximum positive state sum. And the last continuous negative state sum will start from the norms of I, because now I am starting my negative trend, and the current negative state sum stores the whole sum of the negative trend. Since now we moved from positive trend to negative trend, we will reset our variable or segment sum, which is current continuous positive state sum, and we will initialize the sum ending at value at index I to norms of I, because now we are changing the state, and when we change the state we always keep the sum ending at index to the same value of the array. So this is the second condition when we are at increasing trend and we see a decreasing trend. Now if you are in increasing trend and again you see an element greater, you will continue in the increasing trend. When you continue in the increasing trend, the continuous positive state sum will be incremented by norm of I. Sum ending at I will capture the maximum positive state sum ending at I, which will be combination of the current element and the maximum between the last element and the last maximum sum. You can analyze it and you can understand why we are defining it like that. For an example, if minus 2, 2 and 3 are 3 elements, and I'll ask you, give me the maximum sum ending at 3 having positive trend, will you include minus 1? So minus 1, 2, 2, 2, 3 all are in increasing trend. So if I ask you what is the maximum sum ending at 3 having increasing trend, you will not include minus 1. You will always include 2 and 3, which is 5, because my adding minus 1 will decrease the value. So that is the reason we are taking maximum between the last element and the maximum sum ending at last element. And since we are getting increasing trend, we are getting increasing trend again in the increasing state. So there is a possibility that we will calculate our Trionic subarray, which means we will find our Trionic subarray. So how will you validate that you are having a Trionic subarray ending at a particular index? It will be when all the three segment sum will be having valid value. So let's say the first segment sum and second segment sum and third segment sum, if all three are available, that means now you can calculate your current triple sum. So that means there exists a valid Trionic subarray ending at index I. So you will calculate the maximum sum by adding them all, and you will update the maximum triple sum. Coming to the last state, which is decreasing state. So let's say you are in decreasing state and you encounter the same element. It is the same as we have done in increasing state. If you encounter the same element, that means you will reset everything. You will go back the neutral state and you will set the sum ending at array value same as the array value, which is norms of I. But if you see decreasing trend, which means the current element is less than the previous element, which means you are already in the decreasing state and now you are encountering a less element. That means you will simply continue in the same state, which is -1. You will increment the last continuous negative sum by adding norms of I, and the sum ending at I again will be incremented by norms of I. Let's come to the last condition, where you are in decreasing state, but now you encounter an increasing value, which means you are moving from decreasing state to increasing state. If you move from decreasing state to increasing state, so you will first calculate the sum ending at I to be norms I minus 1 and norms of I. So norms ending at array captures the maximum sum ending at that index having the current trend. So the current trend is positive, and the trend always consists of two elements. So unless you have two elements, you cannot say whether you are decreasing or increasing. So let's say you are at 2 and now you encounter 0 and then you encounter 5. So 2 to 0 is decreasing trend, 0 to 5 in increasing trend. So the sum ending at 5 would be 0 plus 5. At least you will consider two elements, whether you are increasing or decreasing. So the sum ending at I will be sum of the current element and the previous element. The current continuous positive state sum. The current continuous positive state sum will be initialized to norm of I. So this is the third segment. So in the third segment, the starting of the third segment will always capture single element, which is norm of I. And since you are moving to increasing state from decreasing state, you will always find a Trionic subarray, and the sum of the Trionic subarray will be combination of the three segment, and we will calculate that and will update our maximum triple sum, and we will change the state to positive, obviously. So by iterating over the array and calculating the condition and then executing the logic of changing this segment sum and setting the sum ending at array, we will eventually find the last triple sum. Let's now understand it through an example. So we have the array present having 0, -2, -1, -3, 0, 2, -1. Let's see how this algorithm will help us find the maximum Trionic sum from this array. So first we will initialize all of our variables. The first element is 0. So the state would be initialized as neutral, which is 0. Sum ending at I at neutral state will always carry the array element, which is 0. The last positive state sum, the last continuous negative state sum, and current continuous positive state sum all will be initialized to minus infinite to represent they are not set yet. The triple sum will be not applicable since we do not have the segment sum available. Coming to the second element, which is minus 2. The second element is less than the current element, and now we are in neutral state. So in neutral state, if you find same element or less element, you will not do anything. So the state will stay as 0. The sum ending at I at when the state is neutral will carry the array element, which is minus 2. The last maximum positive state sum, the last continuous negative state sum, and current continuous positive state sum. So among all these three, if you are at neutral state, the last maximum positive state sum will be stay as minus infinite. Last continuous negative state sum will stay at minus infinite, and so does the current continuous positive state sum, and triple sum will be not applicable since not all three segments are present. Now coming to the third element, which is minus 1. Minus 1 is greater than minus 2, which means it is the start of our first segment. The state would be 1. The sum ending at I will be num of I plus num of I minus 1, which is minus 1, minus 2 plus minus 1, which will be minus 3. The last maximum positive state sum will stay as minus infinite. The last continuous negative state sum will stay as minus infinite, but the current continuous positive state sum will start, which will same as sum ending at I, which is minus 3. And triple sum will not be applicable here because we do not have all the three segments available. Coming to the next element, which is minus 3. So minus 3 is less than minus 1, which means we are going into decreasing trend, and the current state is 1, which means we are moving from segment 1 to segment 2. The state would be decreasing, which is minus 1. The sum ending at I will be the array element itself because we are changing state, which is minus 3. The last max positive state sum will be initialized as the current continuous positive state sum. So the current continuous positive state sum was minus 3. Now it will be copied to last maximum positive state sum. The last continuous negative state sum will start from the same element. The element is minus 3, so it would be minus 3. The current continuous positive state sum will be reset because we now moved from state 1 to state minus 1. So it is no longer valid. So it will be minus infinite to represent it is not set. So triple sum will not be calculated because we do not have all the three segments available. So it will be not applicable. Coming to the next element, which is 0. 0 is greater than minus 3, means we are going to the increasing state. Currently we are at a decreasing state, but now we are going into increasing state. That means we'll change the state to 1. The sum ending at I will represent the maximum positive sum ending at the current element, which means 0 plus minus 3, which will be minus 3. The last maximum positive state sum will stay as it is, which is minus 3. The last continuous negative state sum will stay as it is, which is minus 3. The current continuous positive state sum will start from the current element because we are changing state from negative to positive. So the current element will be copied to the current continuous positive state sum, which is 0. And since all the three segments are available, we'll calculate the triple sum, which is minus 3, and 0, which will be minus 6. Coming to the next element, which is 2. 2 is greater than 0, which means we will continue on the positive state. So state will not change. Sum ending at I will be the maximum positive sum ending at 2 in the increasing state. So if you notice, we have the increasing state minus 3, 0, 2. But the maximum positive state sum ending at 2 will not include minus 3 because minus 3 will decrease the value. We'll simply include 0 to 2 and the answer would be 0 plus 2 will be 2. So now you can imagine the logic behind calculating the maximum, the sum ending at index I to be the norm of I plus maximum of norm of I minus 1 and sum ending at I minus 1. Now you can relate and understand the formula we discussed during the pseudocode. The last maximum positive state sum will not change, it will be minus 3. The last continuous negative state sum will not change, it will stay as it is. The current continuous positive state sum will be incremented by the array element, which was before 0 and current element is 2, so 0 plus 2 will be 2. And now since we have all the three segments available, the triple sum would be minus 3, 2, which would be minus 4. So pardon me for the mistake. This is not 4, this is minus 4. So minus 3 plus 2 would be resulting into minus 4. Coming to the next element, which is minus 1. Minus 1 is less than 2. That means we will go to decreasing state. Currently we are at increasing state. So we'll go to the state minus 1. Since we are changing state, the sum ending at I will be initialized to array element, which is minus 1. The last maximum positive state sum, the last maximum positive state sum would be copied from the current continuous positive state sum, because we are moving from positive state to negative state. So the current continuous positive states will become the last maximum positive state sum, which is 2. The last continuous negative state sum will be initialized to the current element, because we are just entering into the negative state, that is minus 1. And the current continuous positive state sum would be reset, because now we are no longer in the positive state, so it will be minus infinite. And since we do not have all the three segment sum available, the triple sum will be not applicable. So while iterating over all the elements, we'll maintain another variable, which is the maximum triple sum. That would be the maximum of all the triple sum at each index. And as you can see, maximum of all would be minus 4. So coming to the conclusion, we understood the core concept of the problem, and second, we understood how state machine can solve this problem. Third, we went through the algorithm implementation and understood by an example. So if you are interested, you can go over the article that I have pasted in the descriptions. So there I have given detailed description of how to approach this problem and how to solve this problem. And the overall time complexity of this algorithm is order n, because we are iterating the array once. And coming to space complexity, again it is of order n, because we are maintaining an array, that is sum ending at I. And so in total, both time and space complexity will be of order of 1. And just for the motivation, this algorithm beats 100% of the lead code runtime. So thank you all for listening. Please put in the description how you found this solution and what new videos you would like on the DSA and or LLD.